All this requires quality software, and quality software can be built only using software engineering tools and techniques. There are still many reports of software projects going wrong and software failures. Software engineering is sometimes criticized as inadequate for modern software development. However, these so-called failures are a consequence of mainly these two factors. The first one being increasing demands. Systems have to be built and delivered more quickly according to the expectations of the user. Also, larger and more complex systems are requested by clients or users. So software engineering tools and techniques have to be robust enough to meet these increasing demands. It is also relatively easy to write programs without using software engineering techniques or methods. So many companies do this, and later when the product is ready, you get to know that the product or the software product is more expensive and less reliable than it should be. This is mainly because a lot of patches, updates, changing user requirements have to be integrated into a software product even once it is deployed on field. So if you have not followed protocols or standard operating procedures like software engineering tools, technologies, which are already defined as best practices, you're going to end up spending more money, more time when the client asks for changes, and when these changes have to be integrated into your existing software. Let's go back. The second need for software engineering is abstract and tangible nature of software. When we say software systems are abstract and intangible, it means that they're not constrained by properties that are applicable to materials or manufacturing industry, because these are physical entities. Software is not a physical entity, it's an abstract or a tangible or a virtual entity. So the same physical laws cannot govern software. In a positive sense, this actually simplifies software engineering because there are no limits to the potential of software because it's not physical in nature. However, because of the lack of physical constraints, software systems can quickly become extremely complex. They can be difficult to understand and even more expensive to adapt to change. The third reason why we need software engineering procedures or processes in place is that we have a variety of software. You don't use the same software for different applications. You can have gaming software, you can have software to access databases, to query databases, display results, change data stored. You can have a variety of software. You could have embedded system, like we talk about the software that drives washing machine, the fuzzy logic. If you see embedded systems, what are embedded systems? These are the systems that have a very specific purpose. They are designed for a particular purpose and they are the best at what they do. Let me give you an example. Take a DSLR camera. It has only one purpose: click good quality pictures, and it is best at that. That is why it's an embedded system. You cannot do anything other than clicking pictures or recording videos using that camera. Take your mobile phone. A mobile phone is more of a generic system. Using a mobile phone, you may use messaging applications, you may use social media, you may use Excel sheets, spreadsheets, Word documents, you may play games, and you can also click pictures and record videos using the phone camera. But compare the quality of these pictures to the quality of the pictures you have taken on a DSLR camera. See the difference? An embedded system is the best at what it is supposed to do. Take a microwave oven. What can you do using an oven? You can cook, You can reheat food, you can bake a cake, you can set the temperature and other control systems only to do these tasks. There is nothing else you can do with it. And it is best to do things for what it is designed for. That's what we called as an embedded system. And there are specific softwares like fuzzy logic, which are put in place for that embedded system to work. And you cannot use an embedded system for any other purpose. So that's the difference between embedded system and generic systems. Coming back to the variety of software, so I told you that there are software systems, designed for a variety of applications. So it's pointless to look for a universal notations or a universal process or a universal tool, because the software system to be developed itself is different. So we cannot employ the same software engineering tools and techniques to develop all of this. There's no one size fits all. So developing an organizational information system is completely different from, say, developing a software system for air traffic control, or developing a GUI for an intense or graphically intense gaming, right? Since all of these systems have nothing much in common, you also need to apply different software engineering tools and techniques in order to develop this variety of software. To summarize, in this lecture, we have learned the role of software engineering in the modern world and how we can use or build robust systems, software systems, by making use of software engineering technology. We have also learned that software systems are abstract and intangible because they are not constrained or governed by policies or regulations that are applicable to physical systems like a manufacturing unit or materials. We've also learned that softwares come in variety. So you cannot use the same software engineering principle or process to govern the software that you're going to develop for different applications. We've also learned that in spite of the benefits of software engineering, there are reasons why sometimes we have to come across and face something called as a software crisis. This is basically for two reasons: the increasing demands in terms of timing, in terms of complexity, that is, the customer always wants you to deliver a software product quickly. And most of the time it's a large complex software, but still it has to be delivered within the time constraint. So that time it's always a temptation for us to directly write the code, write the software without following adequate software engineering techniques. And we consider software engineering to be inadequate because we have so much at hand and it has to be done within the time constraints. Even though certain companies, continue to do things without using software engineering practices in place, in the long run, because most of your time and most of your cost requirements are going to change. New technologies, new techniques, new features are going to be out in the market every other day, and you have to integrate them in order to keep your software alive. And when you do not follow software engineering practice, becomes extremely difficult, and it's going to cost you in terms of time and money. In this session, we have hence learned the importance of software engineering techniques, which we are going to learn in detail in the upcoming lecture videos.